Hey guys, so in the last video we talked about how to take the equation of a parabola in vertex form and figure out what the vertex is. And what we've done, what we did at the end of the last video was we drew out our Cartesian plane and we plotted our vertex. So this is our vertex at the point -5, 4. On the exam, you don't have to label this point. It's kind of good practice to label the point just so you don't kind of get lost while you're working on the question. -8, -9. All right, so it's good practice, but I won't dock you marks if you don't do this. Okay, now the next step. First of all, let's forget about this -2. First, we got to figure out how do you graph a quadratic. So normally, if you started with 0, then however many units you move in the x direction, you move up that number squared in the y direction. Okay, so if you started at 0 and you hopped over 1, 2, 3, you have to go up 3 squared units. 3 squared is 9, so you'd have a point somewhere like up here or something. My graph isn't big enough for that. But that would be if you were starting at 0, 0. We're not starting at the origin. We're starting at the point -5, 4, and we're going down. We're not going up. Okay? And the reason we're going down is because of this negative sign right here. Okay? So we've got -5, 4 as our vertex. So what this is telling us is that what this negative sign is telling us is that if we go some number of units in the x direction, we go x units that way, whatever number, it could be 3 or something, then when we go down, we have to go x squared units down. So basically whatever number we go over, if we go 3 units this way, we have to go 3 squared units that way. And the reason we're going down is because of that negative sign. If there was no negative sign, then we'd be going up x squared units. Okay? But we're also we don't just have a negative sign, we have a -2 there. So what this 2 is telling us is that instead of going just x squared units down, when you're done that, you have to double it. You have to take this number and double it. Multiply it by 2. Why 2? Because there's a 2 here. If this was a 5, then whatever x squared is, you would multiply it by 5. All right, so let's see this in action. So we start with our vertex at -5, 4, and let's move over 1 unit in the x direction. Okay, we move over 1 unit in the x direction. That means we have to move 1 unit squared in the y direction, right? 1 unit in the x direction, square it. So that means that you're taking that number and multiplying it by itself. 1 times 1 equals 1. No problem so far. All right, so if we didn't have this 2, then we would only go 1 unit. But once we've done this number times itself, now we have to remember that we've got a 2 up here, and we got to multiply this number by that number. Okay, so we got 1 squared, 1 times 1 equals 1, but now we have to double it. So it's going to actually become 2, and because of the negative sign, we're going 2 units down. So we go 1 unit over, 1 unit down, and then a second unit down, and we plot our point right there. Okay? So we got a point there. You can actually do the same thing without really doing any math. Do the same thing on the other side. Go 1 unit over, and then go 1 unit down, and go a second unit down, and plot your point. Okay? And you don't have to draw these lines. I'm just drawing these lines because I don't have a grid. Okay? So you got something like that. Now, let's go 2 units over. If you go 2 units over, 2 units over to the right, then you're not working with 1 squared anymore. Now you're working with, you've gone 2 units over, so now you're working with 2 squared, which is 2 times 2, which is 4. All right, so now we've got this 4, but because we have this -2 up here, we've got to double this 4. So instead of 4, it becomes 8. And because of the negative sign, we're not going up, we're going down. So we're going down 8 units from here. So we go 1, 2, 3, 4, right down to the axis, and then 5, 6, 7, 8, right to about there. Okay? I'm just getting rid of these lines. So there you go, you've got your next point plotted right there. All right, now same thing on the other side. We go 1, 2 units over, and then we do the same thing. We go down 8 units from there, and that takes us over here to -4. And we plot our point, and then we can get rid of the lines. Okay, so now at this point you could continue if you want, but you don't really have to. You can stop here and then just try and smoothly connect all of these things, especially if you're running out of space. The next number, if we wanted to do it, if you went 3 units over, you'd be dealing with 3 squared, which is 9. 3 times 3 is 9. But then you'd have to double it, and you'd have to go down 18 units, which would take us to -14. So basically this distance times 2 down there. So it would be somewhere, well below the blackboard. So obviously we can't plot that one. So this is all that we can really do. We plot the vertex, and then these points and those points, and that's it. Now you got to connect them. But also make sure you extend them to the edges of your graph. All right? So to the edge of wherever the axes are. If it's at the very bottom of the page for some reason, then right to the end of the page. I could have gone right to the end of the blackboard, but I stopped my axis a little bit short, so that's why I stopped that a little bit short. And then same thing on the other side. Try and make it a smooth curve. You don't want it to be pointy at the top. And then if you want, I won't dock you marks for this, but I may give bonus marks for it. Put arrows at the end, because that tells me that you know that this is going to continue on to infinity in the negative direction. All right, and it's the same thing if you had a parabola that's opening up in the positive direction, then to draw those arrows in so that you know, or so that you're communicating to me that the parabola doesn't stop here just because you stopped calculating here. You know it goes all the way to infinity. All right, so that's it for vertex form. You'll only be asked to find the vertex and maybe to graph a couple, and that's kind of it. That's it for vertex form. So the next thing we're going to talk about is factoring. And we might not get through the graphing of this all in one video, but we'll try and get through the process of factoring in this coming video. And I haven't deleted any of the PowerPoints, so if you guys want the notes and you don't have the notes on like the steps on how to factor or anything like that, send me an email, send me an Instagram message or whatever. If your parents have WhatsApp and you have my WhatsApp number, then send me a message there, or leave a comment or whatever, and I'll figure out a way to get that information to you. Now, because my semester is very much underway and I've got assignments and things going on, I might be a bit slower to check those things, and I might be a little bit slower in getting that information to you, but I will be checking my email more and more in the coming week or two, because I know you guys have your exams coming for these classes. So I want to make sure that I'm able to provide you with those resources should you need them. Okay? So standard form. Let's remind ourselves of what this is. So there's 2 ways you can write it. One is with a y in front, the other is with a 0 in front. I'll put the y in front, but when you're working with it, for the most part, you're going to want the 0 in front, okay? So y equals ax squared plus bx plus c. All right? So that's the equation of a parabola in standard form. Now, this doesn't correlate quite as nicely as the other one did for actually graphing it. There is a way that you can use these 3 numbers, a, b, and c, to figure out the vertex and to figure out where to go from there, and you could plot them the same way, but I think it's a little bit more complicated. Plus, the factoring technique that we did in class proves to be very useful in other in other areas of physics and math. And on the other blackboards going that way, there's a bunch of math from one of the physics questions I was doing where we needed to use some factoring skills. So this stuff is applicable in university math should you ever take it. All right, so when you're factoring, let me sort of create an example so that we know what we're working with here. So let's say y equals, no, I don't want 3. Let me just make it simple for now. Y equals x squared plus, let's say 4x, and then let's make this a 3. Okay, x squared plus 4x plus 3. On your exam, I'm going to try not to go back on my word. If I go back on my word, it's only because I forgot, but otherwise I promise to make sure there's no numbers in front of this except for a 1. So I won't put like 11 or 5 or anything like that. The most I might do is 2 or maybe 3 if I do go back on my word, but it won't be something crazy. It won't be like 25 or anything like that. Okay, so you never have to worry about a big number in front, and hopefully just a 1 or maybe a -1 or a -2. Okay, so if this is what we're working with, we got to figure out a few things. First, we got to figure out what our a value is, and what our b value is, and what our c value is. Okay, so our a value, you basically just look at whichever term has the x squared in it, and you look at the number in front of it. If there's no number in front of it, there's a 1 there. There's an invisible 1 there that likes to hide. It's kind of shy. So your a value is 1. Okay, your b value, you look at the term that has an x in it, and you look at the number that's attached to it. So in this case, our b value would be 4. And the last one, for our c value, it's the number that's by itself with no x attached to it. So in this case, c is 3. Now, if your a value is bigger than 1, then it'll also be useful to calculate a multiplied by c, which will be a different number if this is not simply a 1. In this case, it is just a 1 here and a 3 there. 1 times 3 is 3. So our a times c value is also 3. Now I'm just going to move this, or I'm going to get rid of this and then start writing the next step up above. All right, so you can copy this down, or just pay attention for now and copy it down later, rewatch it or something like that. But so our next step is we want to find two numbers, m and n, let's say, such that m plus n equals our b value, and m times n equals a multiplied by c, or in this case, just the c value, because these two are the same. Okay, so we want two numbers, m and n, such that they add to give us b, and they multiply to give us a times c. Okay, so we want something plus something that equals b, and something times something that equals AC. Now our AC value is 3, so I'm going to write that in up here. And our B value is 4, so I'm going to write that in over here. So we need two numbers that add together to give us 4 and multiply together to give us 3. And if you haven't figured it out, then I'll give you, I'll make it easy for you this time. One of those numbers is 3, and the other one now should be very easy for you, is 1. All right, 3 plus 1 is 4, 3 times 1 is 3, all is good. So now I'm going to get rid of some of this. And our next step, maybe I'll get rid of this as well. I'll write it up here somewhere small. Y equals x squared plus 4x plus 3. And now we want to break up this function into more but smaller bits. Okay, so we start with well, we don't want a y at the beginning. We want a 0 at the beginning, or at the end if you wish. But 0 equals the x squared term and if there's a number in front of it, don't touch it. Leave it alone. Then you have plus. Your b term gets broken up into those two numbers that you found, m and n. And then your c term, don't touch it. All right, so our b term used to be 4. Our m and n values are 3 and 1, so we just plug those in. So instead of m, we'll write a 3. Instead of n, I could write a 1, or I can just leave it. All right, I don't have to write a 1 if I'm multiplying by 1, because it doesn't change anything. Now, if you look at this x and that x, they don't have any numbers in front of them except for 1, and they're so far apart from each other. And similarly, this 3 and that 3 are so far apart from each other. They want to be closer together, so we'll just swap the positions of these two. All right, so we'll make it 0 equals x squared plus x plus 3x plus 3. Now they're happy because the x's are together and the 3's are together. Okay? So the next step is to section this off into 2 chunks. The first chunk is that one, x squared plus x, and the second chunk is that right there, the 3x plus 3. All right, hopefully you can see the boxes. I tried to make them light just so that they don't really get in the way. So we've got x squared plus x, and what we want is we want to find what is in common between these two. All right, I know this video is going to be a little bit long. We're not quite finished yet, but I'm just going to finish this example and then we'll stop. So we want what's common between these two terms, and the only thing that they have in common is an x. Now if you divide both terms by that x that they have in common, what are you left over with? If you had x multiplied by itself, x times x, but then you divided one of those away, you're only left with 1x. So this term, the leftovers, is just 1x. That term, you've got x divided by x. There are no leftovers. X divided by x is 1. So it's tricky. I can't say that there aren't any leftovers, because if there aren't any leftovers, you wouldn't put anything here. But the leftover is 1. X divided by x is 1. Keep the same sign that you had in the middle, plus 1. As long as this value is not, it doesn't have like a negative sign in front of it, which hopefully it won't for any of your questions, just keep the same sign here. And then you'll do the same process for this. 3x and 3, what do they have in common? Once again, keep that sign the same. 3x and 3, what do they have in common? They've got a 3 in common. When you divide out 3 from 3x, you divide out the 3, you're left with just x, so you put those leftovers there. And then 3 divided by 3, you're left with 1, and you keep the same sign, x plus 1. You'll know you've done it right if these two brackets read the same thing. Okay, your next step is, if you wish, let's give that bracket a name, and we have traditionally gone with p, so we'll keep it with p. All right, so now your next line would look something like 0 equals x multiplied by p, because p is representing those brackets, plus 3 times p. All right, now you can see that both of these have a p in common. So you factor that p out by writing it in front, and then you put the leftovers in the brackets. xp divided by p, the leftovers is just x. 3p divided by 3, the leftovers you get are just 3. And you keep the same sign in the middle. So you've got p times x plus 3. But we made up p. We can't just pretend that p was something that the reader understands what we're talking about. It's always a good idea to make a statement before this line that says, let p equal x plus 1 or whatever. But you don't have to do that. But in this case, p was x plus 1, so we've got 0 equals, we sub that back in. So p was x plus 1, so we write x plus 1 instead of p, and then we write x plus 3, just as we had it. And we're almost there. We're now almost finished. This is in factored form. So this, we started with standard form, which was that ax squared plus bx plus c. This is factored form. And once again, if you want to graph this on the internet, you can't have a 0 here, you'll need a y here. If you keep a 0 here, it'll give you 2 vertical lines. You want a y here if you're trying to see a graph of this on that website that I told you about, Desmos. But this, otherwise, x plus or minus some number in brackets times another pair of brackets with x plus or minus something else, that's factored form. Your last step is simply to tell me what your x values are. So either, for this statement to be true, 0 equals something times something. One of those somethings must be 0. It doesn't matter which one, but one of them has to be. So either x plus 1 equals 0, or x plus 3 equals 0. Okay, so we've got x plus 1 equals 0, or x plus 3 equals 0. So if x plus 1 equals 0, then you can get rid of the 1 by subtracting 1 from both sides. So you got x plus 1 minus 1 equals 0 minus 1. The plus 1 and the minus 1 will cancel each other out, leaving you with just the x, which is what you want, equals 0 minus 1. That's just negative 1. On the other side, you do the same thing, but with a 3. X plus 3 minus 3 equals 0 minus 3. And the positive 3 and the negative 3 on the left side will cancel out. You're left with just an x equals 0 minus 3, which is negative 3. And those are your two answers. If I ask you to factor but not graph, this is where you stop. Okay? And if I say you can leave it in factored form, then you can even stop up here. But your best bet is to get to this point, that x equals this or x equals that. Okay? And in the next video, we'll talk about what this means and where to go from there. All right, so we'll see you in the next video. We will finish up quadratics there, and then if we finish that one a little bit early, we'll start our trigonometry review.